it will be list comprehensions. And list comprehension, what is that? So before we were doing something like this. Suppose you needed to find all the numbers that are divisible by 3 from, say, numbers 5 to 100. So how would you do that? Well, you would do n equals to empty string. Now, empty list. Now, because I don't want to just execute right away, I'll open a bracket and then enter so that IPython will give me a new line, and then go back, finish that off, and then now the following code is not the most efficient one, but I just want to show how list comprehension works. So let me show you this case. For x in range, say 5 to 101, that will give you all the numbers from 5 to 100. And then I am going to test something on the x. So if x percent 3, so the percent is called the mod function. What it does is it divides x by this number and gives you back the remainder. So for example, if you divide 5 by 3, well, 5 divided by 3 gives you 1, and the remainder is 2. So this x percent 3, or x mod 3, will give you 2. If you do, say, 12 mod 3, then 12 divided by 3 gives you 4, and there is no remainder. In that case, remainder is 0, right? So you get 0. So if I want to figure out which numbers are divisible by 3, you would test whether this is equal to 0. This mod is 0. And if that is true, then we would append that number to n, right? So we would do n dot append x. And then if I just hit enter and then look at n, it gives you all the numbers that are divisible by 3. Right? Yes. The commas?
Yeah, like it says 12, 15,
Oh, so you don't like the way it's printed? That's what you're saying, right? Okay. Well, you can print it. Let's see. So you can first run this, and then you can do for I in n, right? Print. You can do I, but end instead of commas, we'll put a space. Okay? And then once you end, now you go backspace so to get rid of the tab, and we want to have a print statement at the end because at some point you have to have a new line. So this will give you a new line. So if you do that, you're going to get all the numbers that are divisible by 3. Okay. Now, what is list comprehension? Well, list comprehension is a specific command style in Python that's designed to shorten some of the for loops and if-then. So if you code a lot of Python, you will realize that there are many cases that you write codes like this. Now, you would rarely do this way of coding when you're coding in C++ or even Java, because the lists are not native or first-class citizens of those languages. Here, lists are first-class citizens. It comes in Python as a default, so we end up writing a lot of code like that. And the list comprehension makes this way of coding into just a one-liner. And let me show you how that's done, you first open a bracket and say, we do two things. We first want to collect x, okay? X for x in range 5 through 101. Okay? So there's the for statement. But you don't do colon. Instead, you go to if, okay, x percent 3 is equal to 0. And then you close the bracket. If you press enter, you get the same result. Right? Okay. So the list comprehension has the following structure. You open the bracket, you tell what you're trying to collect and what you're trying to iterate, okay. And then you put an if statement if you need to. Okay. So anything that meets this condition will be collected. If this condition is not met, it's going to skip. So this could be a way to write down this could be a way to write down some cool things. So, for example, let's import random. Then we will do random.randint, and it gives you a number between something. So let's say 1 through 100. Okay. So if you wanted to collect 100s of these random numbers, you can use list comprehension like this one. You can, let's say a equals to, open a bracket, we will do random.randint 1 through 100 for I in range 100. Okay, so first of all, notice that we didn't put any if statement here, so everything will be collected, but instead of collecting the i's, we will just collect some random number. So this can create a list of 100 random numbers without having to use a for loop. The for loop is inside the list comprehension. So if I look at A, you see that this is made up of different numbers, 1 and 100 inclusive. So 100 is a possibility. And now let's say out of these numbers, we want to collect all the odd numbers. Okay, so how would you do that? So let's see, A odd equals to, we're collecting number n for n in A. So we're going through all the numbers in A, and we're going to collect n. But we only want to collect it if it's an odd number. How would you write that? Yeah. So you need an if statement first, right? So you need if, and then n mod 2. Now, for an odd number, what happens if you mod it by 2? Yeah, it should be 1, right? So you do that, and then if you print A odd, you see that now it went through all the elements in the list and only collected the odd numbers. Is that okay? Yeah. That's called list comprehension. Yes?
You want the mod, so if it's mod 2, you want it equal to 1 always to get the odd numbers.
I mean, think about what an odd number is. What's an even number? Numbers that are divisible by 2, right? So what's an odd number? If you divide the number by 2, you would be getting a 1. That's another definition of what an odd number is. And that's why I'm using it this way. 2023 to 2024 NBA player stats. And put Kaggle in there. And you should be getting Kaggle website. Now, Kaggle is a website to like train yourself with machine learning. It has lots of tutorials in learning machine learning, and it has competitions, it has models, it has example codes, it also has data sets. Nice thing about Kaggle data sets is that it's already made in the form that's easy to process in Python. So let's see. You have this 2023 to 2024 NBA player stats, playoffs.csv. Let's download that. Okay, where did I? Okay, so I downloaded it. Now, last time I asked people to put the downloaded file into the correct the same folder. This time, let's try to find out how to have access to any. And you look for the properties. Mine's in Korean, but it should be something like properties. And if you look at it, there's a file name and there's a path. What you want to do is you want to copy the path and say path equals to open a quotation, paste it. Now, there's something with Windows users. Well, when Bill Gates made his Microsoft Windows, he made a bad decision to take the what's known as the common slash, /, and he used backslash, and messes everything up because in Python, for example, \t is tab, so it will recognize it as completely different. So what you need to do is you have to take all the backslashes and make it into /. Now, Mac users don't have to do this. Okay? It's already /, so there's nothing to change. And by the way, your path names will be all different, so don't type this. You should right-click, look at the properties, make sure that you have the correct path name. Yes. Oh, I also added the / at the end because now I'm going to copy and paste the file name. Okay. So now what you want to do, is go back to the file name, copy the file name, copy that one, and if you haven't put this slash, put the / again, Control V, and then enclose this with quotation mark. That will be the path of the file. Okay. Now notice that this is a CSV file, which you could still process it. I mean, you can read it just like with open path as f. Okay, and then for L in f, print L. If you run this, it's going to give you all the lines. Now, if you add it to something like D for data, D is equal to empty list, and then instead of printing, you can add it to you can append it to D. And then if you look at what D of 0 is, it has all these things. D of 1 gives you the next row. 2. Okay. So this is the stats of everyone who played in the playoffs. And there's various stats. And then, yeah, you can do this, but instead of doing it this way, you can use something called pandas. Now, if you're a data science major looking at a lot of data, then this will be the most used package in your entire career. Okay, so import pandas as PD. That's the standard way we import pandas. So we're going to import pandas, but we're going to rename it as PD because writing pandas all the time takes time. So we're going to do that. And then instead of trying to read D like this, we're going to say df equals to PD, read, and then if you do tab completion, it will tell you different things. So there are several things. So you can read CSV, which is our file. You can also read Excel. Feather is like a file format for big data. And then you can also read HTML. JSON is a file format for HTML data or JavaScript data. Parquet is another one. So there are so many different types of data you can read from pandas. So it's a very convenient package. We're going to choose read CSV and open and then path. Okay. And then DF comes with several nice languages. So pandas mainly uses this thing called data frame. That's why I named it DF. So this data frame has several methods in there. One of the things that you want to do is df.head and open parenthesis, close parenthesis, and then it gives you, the problem is the separator here is not the usual comma, and it's a semicolon, so it didn't correctly divide things into columns. So let me read this again, okay? So we're going to do df.read CSV, and then comma, we're going to say separator equals to semicolon, just like that. Okay, now let's do df.head. Beautiful. So you kind of see what's going on here, right? So you have player number, player, position, power forward, team New York Knicks, steals, blocks, turnovers, fouls, points. Something like that, right? Let's look at the columns and see what these are. df.columns. It says RK. I don't think that's rank, because these are not like fantastic players. Player, position, age, team, game, games. I don't know what GS would be. MP. Do you know what MP is? I have no idea. Minutes played, right, thank you. And then field goal attempted, field goal percentage, 3 points attempted, 3-point percentage, 2 points, and then effective field goal, free throw, and offensive rebound, defensive rebound, and all this. Okay, so that's data frame, okay? Now, I probably want to spend some time talking about pandas package more, but today let's just try to extract some data from this data frame using list comprehension. So what we could do is let's collect all the x's for x in df.iter rows. I'm just going to do ITER and then tab completion. It says iter items, iter rows, iter tuples. So I'm going to do iter rows and then open close parenthesis. If, okay, 3-point percentage averages more than 33%, 0.33. I should have looked at what it is. Okay, let's just look at points. Points is, say, 20 points or more. Okay, so if X PTS, now each row acts like a dictionary. So so you're going through each rows of this data frame, and we're looking at, you're fetching the points of that data. Okay? So that's the way we do it. X bracket point PTS, and then if this is bigger or equal to 20 points. Okay, so let's see who are the high scorers here. So for some reason, okay, so I see, yeah. So I just had a hiccup. When I actually did this and looked at what it fetched for each X, somehow strangely it will give me a tuple of three things. A number, I guess that's like the number, the entry number for this object, okay? And then it will give you an actual row of the data frame, and it will also tell me the object in this way. So if I want the actual data, the actual row, I have to say bracket 1 first to fetch the actual information. Okay, so that's something I didn't realize. Okay, so so let's do this. List comprehension. We're going to do X of 1 because that's the actual player data that's going to be collected. Okay, so and for X in df.iter rows, if X1 and then points. Okay, is greater than 20. Greater or equal to 20. So we'll include the 20 as well. Okay, so now let's see what happens. Oh, several people. Okay, let me show it again. Instead of collecting all the player info, let's just collect their names, okay? So player. So let's see, player. Okay, so let's see. Okay, so here they are. So these are the players. I guess some European names are not correctly written. So these are the players who got an average of 20 points or more in the 2023-2024 playoffs. Okay. What if? What do you want to look at now? Now we can just change things and have fun. What do you want to look at? How about 3-point percentage? So what is that? 3p%. 3p% has to be greater than 33%. How's that? 33. Oh, there are several. Okay, that's, I guess I'm being too generous. What about 40%? That's a lot. Oh, really? In the playoffs, there are so many people that has 40% or more? Oh. What if I do 50%? I guess, you know, some people who did not play many minutes, yeah, so most of these people we don't remember. Okay, but they got 50% or more 3-point percentages. Maybe we should limit this by minutes played. So how much is minutes played? MP. If I do 100, is that a lot? Oh, nobody plays more than 100 minutes. Okay. Oh, maybe it's like not the total minutes played, but average minutes played per game. So that's probably like 30 minutes. Okay, so we have people who play more than 30 minutes. Okay, so let's say we want to know how many people during the playoffs played 30 minutes more per game and also got 40% or more three-pointers. Okay, so in that case, and x1 3p% has to be bigger than 40%. Oh, I forgot to close this. Okay. Okay, what's that? Oh, wow. Oh, really? Okay. I guess for playoffs, when you're only playing a short week, that short few weeks, you might be able to do well. Pretty impressive. Okay. I wonder who got like 45% or above. Oh, 3 people. Okay. All right, so that's like a demonstration of what you can do with list comprehension. So you have the for loop and an if, and you can collect whatever you want as this for loop goes. Now, just to understand this better, let's unpack this into long form, how that works. So this short one-liner command that we just did, if you want to expand it, if you say your player list is equal to empty list, press enter right here so that it will give you multi-lines. Go back, finish off the empty list. And what we want to do is for x in df.iter rows, okay, and then we will put this, we'll copy this one, and we'll put this if statement in here. If this statement, if both of these statements are met, then what we are doing is we're going to do pl.append this thing, the player. And then after everything is done, let's untab it and we'll print. Okay, we'll print pl. And you get the same result that way. Okay, so these few lines do exactly the same thing that this one-liner is doing, so you can kind of see why list comprehension is quite convenient. All right? Okay. Now let's talk about some, so that was list comprehension. Let's talk about some algorithms in Python. We've been working with Python for 2 weeks now, so hopefully you got more used to all these Python commands. But one of the things that you should also learn is how to think like a computer. Computers think a bit differently than how we think. So if we go up, remember how we generated 100 numbers, random numbers here? Let's generate it again. And let's print A. Now, the question is, how would you find the largest number here? What's the largest number here? Oh, maybe it's not so hard, easy to see. What's the largest number? What's the largest number here? There's a 99, right? Now you can quickly see that there aren't any 3-digit numbers. So now you can say, oh, there's 99. That's how humans figure out the largest number, right? But when you say you want to do an algorithmic approach, it's quite different. How would you find the largest number as an algorithm? Well, first of all, you should iterate over each number, right? And if that's the largest, you keep it. But the thing is, you haven't seen what goes later. See, although humans can see all the numbers at once, if you're processing this as a Python code, you can only go one by one, right? One by one. So what you do is you have to look at some number and see if that was bigger than everything that you knew before. And if that's true, then that's the new record. That's the way you would do it. So let me show you how we find the maximum number from A. And by the way, if you just do max of A, you can quickly get the value of the maximum, which kind of spoils the fun. If you're learning how to code in C++ or other languages, usually you don't have a convenience of these commands, so you have to make everything from scratch. So let's suppose that we didn't have that command, and we have to make our maximum function from scratch. How would we do it? Well, let's first open a parenthesis, enter, so that it will give you multi-lines. Now close this. We're going to say highest equals to 0. Now we are assuming that the number that we're trying to process is a positive number. If you don't know that, then this number should be the very first of the list. So you might say A of 0 could be what you want to start with. But we'll just assume that we're finding a highest number among the positive numbers. So we'll have the highest as 0. And we're going to go through for n in A, all the numbers in A. And we're going to compare if what? If n breaks the record, n is bigger than the previous highest, right? Now n will become the new highest, right? So let me give you a minute to think about what I should put in this next line. So you're doing the scorekeeping. If you have a new world record, then the previous record has to be replaced by this one. Okay, so how do you do it? The highest will now be replaced by n. Okay? All right. And then you print highest. Oh, you might have to put some delete commands to get rid of the new lines that you've done. Okay, now press enter. It gives you 99, just as we had before. Okay? Now, how would you do the lowest? Well, instead of highest, we were going to say it's lowest, right? But there's a problem. Lowest, 0 is lower than everything, so this is not good. So you should assign some big number to it. Or this time, let's just say A0, so that it uses some number from A. And then, how do you change this if statement? If the number that you fetched, yes? Less than lowest, right? And if it's a new record lowest number, then the lowest will be replaced, and you put lowest. Okay, so lowest is 2. Do we have a 2? Oh, there is a 2. I didn't know. The 6 would be lower. Okay, 5. Right? So that's how you do these things. In other words, for the reason coding language is hard is, one, you have so many different commands that you have to memorize, but two, sometimes you have to think like the computer. Suppose you had a book on a table and you had to take it and open it. Well, humans just do it. We just take the book and open it. But for a machine, you have to first check if there's something above the book. Let's say there's a coffee cup, then you have to first remove it, put it to some other place, and then take the book out, and then you have to open it. There are several things that you have to ask the computer to do, where humans can just think about everything at once. So that's one of the challenges. So you have a separate course called Data Structures and Algorithms. If you're a data science major, you will be taking that class at some point. If you're not, you can still take it as engineering elective if you want to. And over there, we're going to teach you several algorithms. And one of the most enlightening kind of algorithm is like sorting. How do you sort a given list? Well, again, there is a sort command for every list, right? There's a sort method. But instead of using that, can you make a sorting algorithm from just swapping data from one place to the other? So let me just quickly show you a sorting algorithm. I'm going to show you two things. The first is a bubble sort. The bubble sort works as follows. You start by, let's open a parenthesis and close the parenthesis. Open a parenthesis and not close. You start out by fetching the very first element. No, you don't. Do you have to? Oh, no, you don't. Okay. So we will just go through all the elements. For I in range length of A, and what we are going to do is we're going to subtract 1. And what we will do is, if A of I is greater than A of I plus 1, and the goal is to sort this so that the previous one, the smaller one comes first, and bigger one comes later. Okay. Let me actually put a print statement here. Print A before sorting and print after. Okay. So right now this is not going to sort everything, but I just want to show you what this will do. So if AI is greater than AI plus 1, I'm going to swap those two. So I'm going to say AI plus 1, comma AI is going to be equal to AI, comma AI plus 1. I'm slightly unsure if this is a proper way to do it. To make it sure, I just have to build a tuple, just like this. If I build a tuple, this is fine. I'm building a tuple, and then this just unpacks it. Okay? So I'm going to do this, and after this, I'll print. Okay. So can you compare the two lists and see what happened? 6 is 6, that's fine. What happened here? 52, 14, 14, 52. What happened? They swapped places, right? because 14 is smaller than 52. So just swap places. But then 52 is less than 76, so it's okay. And then before 76 is less than 84, so it was in place. But then this 5, because 5 is smaller than 84, these two swap places. And actually what happened was that because 84 is greater than all of these, it kept swapping with other people, and we went over here. Okay? So you can kind of see that some of these things swap places by looking at the neighbors. You know, have you ever had like a group of people trying to take a photo from the shortest to the tallest? How would you do it? You would just first line up, okay? And then you would look at the next person. If you're taller than the other and you guys need to swap, you would swap, right? And then you look at the other guy again, and if you need to swap, you keep swapping, right? At some point, you swap, and then at some point, you'll end up swapping with everyone, and there's no more need to swap, and you're sorted. That's the idea of a bubble sort. It's called bubble sort because the smaller number keeps going in front, so it's like as if bubbles, when bubbles appear inside the water, it rises up. That's the idea of this sort. It's the most primitive kind of sort. Now, once you have this, you only need to, now, once you have this done, you only need to do it n more times. Actually, there's a bit more efficiency here. You don't have to go through every element until the end. You can shorten this as the loops go by, but we'll not go into details, and we'll just have something that works. So we're going to press the up arrow to bring in the previous code again, and we're just going to put another for loop for j in range of len a. Just do this, and then select the next lines and press a tab to move it here. And if you enter, now what's going to happen is that this process of bubbling up is going to be done 100 times, because that's the length of the list, right? If you do it 100 times and then you print it, then now you've sorted everything. It's done. Okay. So roughly, we call this the order of the algorithm. So roughly, you end up. So if you're trying to sort a list size of n, you end up spending about n squared steps times some constant, we don't know. So it's about n squared because there's double loop here. Okay? So that's what's being done. That's called the bubble sort. Now this is kind of wasteful because if you look at how the bubble sort works, it only compares things next to it. But you know, if you know that you're less than 27, you don't have to compare yourself to 56 because you already know that you're less than 27. Right? There's no need to compare 18 to 56. But bubble sort will compare always to the next guy as you're swapping. You end up comparing yourself to everyone. And one way to help you not do it is something called the Q sort, so quick sort. So let me talk about the quick sort here, quick sort. And let me now get a new random integers. So here's another set of 100 random integers, and I want to do a quick sort on it. So what we are going to do is we're going to add, we're going to divide. So we're first going to fetch A0. So A0 is 49. And what we're going to do is we're going to go through all the members after 0 and then divide into the ones that are lower and the ones that are higher. So what we do is lower is equal to x for x in A, 1 and afterwards. So we don't compare it with itself because the very first one is what we're trying to use it for. And then if x is less than A0, that will be called the lower. Okay. So let's see what's in lower. Print lower. These are all less than 49. Okay. And then higher would be x for x in A, 1 colon, so every other one. And we will collect it if x is greater than A0. Okay, print higher. So as you can see, we only collected the ones that are bigger than 49. Now, the beauty of this is if we sort things in here, and if we sort things in here, we don't have to compare anything in here from here. We already know that all the elements in the first list, in the lower list, will be smaller than the things in here, right? So if we sort this and then put the 49 and then put this one after, then you get this fully sorted list. So so let's see, if you do, so just to make a point, let me cheat a little bit by using the sorted. So lower dot sorted plus A0 as an element plus higher not sorted. Okay. Now, addition for list is list concatenation. You're just putting list next to itself. Okay. So if I do that, oh, it doesn't have sorted. Let me see, dir lower. Oh, I thought it has sorted. It doesn't. Okay. Okay. Let me make this lower 2 as lower dot copy, so that it doesn't mess up the original lower. And higher 2 equals to higher dot copy. And we're just going to sort separately. Sort higher 2 dot sort. Okay. And now let's just add lower 2 plus A0 as a list plus higher 2. Okay, so remember, these are separately sorted. And oh, I should really print it. Print this. Then this is sorted, and what happened is, here's our 49, the one that we started with. And the previous one is sorted, and this one is sorted separately. Now this is actually already an improvement against the previous code, because if you think about it, size n list requires n squared, about n squared operations, right? So if you take a list that's half the size and you square it, the number of operations is 1/4. So if you just do this and then the list is about evenly divided, then you have a lot smaller things to sort, so it's a lot quicker. Okay. Okay. So how do we then try to make a quick sort function? Okay. We're going to do something called a recursive. I'm sorry, I should have shown you some other recursive function examples, but this is going to be your first look at a recursive function. So here's what we're going to do. We're going to do def qsort, quicksort. I'm going to get a list, and we're going to do the same thing that we did before. So lower equals to x for, no, sorry, A0 first. A0, no, A0 is okay. Okay, so we're going to do lower equals to x if x for x in A is the list, and then one colon so that we don't fetch the zeroth one, but if x is less than A0. That's going to be the lower list. And the higher will be basically the same thing, so I'm just going to copy this one. But the only difference is if it's bigger than this. Okay. Now I just realized something. If we do this, then if there's another 49 in here, then it's going to mess up. We have to allow that to be included, so we're going to put equal sign on this one. Okay? So the higher will be the ones that are equal or greater than A0. Okay, so we're going to do this. And what we are going to return is we want to return the lower that is sorted plus A0 as a list, right? Plus the higher as sorted. But then these are not sorted. We just fetched the ones that are higher and lower, right? We have to sort this. So we have to apply some sorting algorithm. And what sorting algorithm can we have? Well, we just built one. It's qsort. So we just apply the qsort to what we have. So what's going to happen? Well, what this is going to do is it will just keep applying itself to sort the smaller ones. And this is called the recursive programming. It's kind of nice. But then the problem is, have you heard of the turtles way down story? Like Bertrand Russell was explaining how the universe is like and how the earth is round and all that. And after the lecture, an old lady got really angry and came to him and said, no, earth is flat and it's not like what you said. And Bertrand Russell asked, well, if earth is flat and it's not moving, what does it rest on? And the lady said, well, it rests on a giant turtle. And Bertrand Russell asked, like, then what's beneath the turtle? And the woman said, it's turtles all the way down. So it's like turtles all the way down. That's like a funny story, anecdotal story. But if you do this, then the list that you get will get smaller and smaller, but it'll be like keep getting smaller and smaller, and it never stops. So you have to, at some point, return something that's more concrete. So what you have to do is put it above here and say, if length of A is 1, then there's nothing to sort, right? So you just return A. Just do that, and then the remaining ones won't be executed if it has length 1, it will just return A and not execute the remaining ones. So this is going to be a very quick sort algorithm, and it's made short just because we're using list comprehension. So list comprehension is quite wonderful. All right, so let's do this and let's see what we get if you do qsort of A. Oh, okay. It's kind of slow. Well, it's conceptually fast, but the problem. Oh, what's happening? I made an overflow. Okay. Oh no. Stack overflow. So what happens is that if you call yourself over and over again, then the stack kind of has the information of where you call this function from, and this becomes overflowing, and then it crashes the kernel. Let me see what's going on here. All right, so after checking a little bit, I realized what my mistake was. Sometimes when you split the lower and higher, this could be an empty list, right? In that case, you should also return the list as well. The thing is, because I didn't handle the case when it was an empty list, it just ignored, when I had this one, when it was an empty list, ignored this one and then executed this again, which just gave you turtles way down again. So to prohibit the turtles going down, way down, you really have to change this equal sign that we had to equal or less, and now everything should work fine. So let's see if I have A as this thing, and now you can do print quicksort A, and now you see that it's all perfectly sorted. That's all. Thank you.